Assalamualaikum warahmatullahi wabarakatuh. My name is Hilmi bin Radzuan, and I will be presenting my final year project proposal, my title was a flight simulator of a Victor bladed swing body UAV for a medical transport, and my supervisor was a Prof TS Dr. Rizal Effendi. And next, the content that I will be presenting today is introduction, problem statement, objective, scope, and the limitation of the project, literature review, methodology, and the preliminary result. First, we come out with the introduction. The medical transport has begun popularity in Africa, where the distance between the hospital and the local clinics is far and only being connected via the off-road trail. This also same case with Malaysia, with most of the distance between the hospital and the rural clinics can be as about 50 kilometers away and can only be accessed by the muddy trail, unpaved road, and the shallow river. The transportation time also take an hours, and emergency supply required to use a manual helicopter, which is expensive for carry a small load. So, to overcome this problem, Flight Technologies and Research Group (FTTC) and the Hospital Sungai Buloh has proposed a vertical takeoff and landing UAV, which means a VTOL, designed for the medical transportation mission profile. In this research, virtual UAV will be designed using S-Plane Maker software. The virtual design data and the flight will be computed using a blade element theory, where all the acceleration, velocity, displacement force, and the moment of are computed in a real time utilizing. So the problem statement is to identify the potential of the current model of the VTOL to reach a 50 km range of medical transportation, identify the suitability of the current VTOL design to carry the load and the potential, collecting the data of the flight test for the improvement for the future. The next, the objective for this study is to relocate the propeller motor location via the S-Plane software, to compute the data of the acceleration, velocity, displacement force, and the moment via the S-Plane. Next, to evaluate the flight dynamic characteristic VTOL and get the maximum flight performance and static and dynamic stability based on the given mission profile, mission requirement, and the payload specification. The scope and the limitation of the project. So the scope of the study is regarding to the current VTOL bladed wing body UAV model and to relocate the propeller motor location, because the current propeller motor location are not suitable with the application due to the position and the movement of the propeller are not suitable. Next, collecting the data of the flight dynamic from the run the simulation and get the maximum performance of the model. So the limitation for this project is because for the current situation, due to the pandemic, we can use the lab to do as a reference for the available product or model of UAVs. The next is the software itself, because the S-Plane software is something new for me, and it takes time for me to understand and how to use it. The next is the S-Plane software that have been provided is a beta version. However, the beta version is already enough for us to complete this study. Next, we come up with literature review. So UAV or the unmanned aerial vehicle are getting popular, and we know the UAV that are really popular among us today is a drone. UAV also can be classified by the vehicle type, size, mass, mission range, and the altitude. UAV is already widespread in the military, rescue mission, package delivery, for example for the Amazon, and they are currently work on it. And they also use for the medical transportation, for example in the east of the Africa from 2016. UAV have been used to deliver a medical supply, especially blood, to the across country in Rwanda, East Africa, and the project are known as a zipline. Even in the Sweden, they have to use the UAV drone to replace the delivery service to send the ultimate external defibrillator or AED. UAV are commonly known as aircraft which are controlled by using a remote via the radio frequency. The next is for this an example of the UAVs. North Gram, Global Hawk, and Pigeon V. They basically used for the military. And next is a drone. Drone basically used for the event, or for example as a motorsport, concert, or any others events. The lastly is the zipline. Zipline is the model that will used by in the East Africa that used to send a medical equipment supply. So the next is study on the F4 design. The design of F4 will be many aspects, because it will decide the amount of lift that be generated and the drag force. There are many available design of F4, for example of NACA, Clockwise, and the NASA. The standard F4 that will be used basically a NACA, and it also come with a lot of design and application. Below is the list some of the F4 from a NACA design. Next, study on the lifting motor rotor. Lifting motor rotor UAV allow to increase the flight range, because the feature of the UAV, if lifting wing will be work together, it will with the rotor to supply the lift when the fly forward. Beside, it also can reduce the power consumption and improve the flight range compared to the original multi-rotor. And in this study, they have shown that from the lifting effect, they have saved almost 50% from a normal flight and increase the flight speed. Next, we come with a workflow. So the first step that will be used literature review. Next, redesign the UAV and the specification, because the first that will need to be changed is the propeller motor position. The third one is apply into the 3D model of UAV using the X-plane. Run a simulation, the same using the X-plane software. Record the data and the analysis. The methodology that will be used are theoretical framework, X-plane software, plane maker, and F4 maker, X-plane simulation testing. So for the theoretical framework, the data such as a free body diagram, equation of motion, coefficient of lift, thrust and motor, propeller thrust, angle of the thrust will be computed using a theoretical framework. The next is X-plane software. For the F4 makers, F4 maker used to generate the F4 design that's suitable with the application. The next is a plane maker. The plane maker is where the design of the airplane will be made and or be modified. So next we come up with the preliminary result. This is an overall view of the planes of the current UAVs that will be used in this study. Here is the example of the simulation testing that I have been done. During the flight, the data such as the thrust, RPM, and the fuel consumption will be recorded. Such as next is the speed, the Mach number, lifting and drag also will be recorded. This is an overview of the plane during the flight and during the takeoff. This is the data that will be carried out from the study. The first data is the V-in. V-in is the speed of the UAVs due to the speed. Next is V-through, is the speed of the aircraft due to the grounds. And the next is a Mach speed ratio. Mach speed ratio is the ratio of the speed due to Mach 1. Next, here is the reference that I will be used to complete the study. And that's all from me, and thank you.